Assalamualaikum and very good morning to our speakers and to our beloved audience. So today, our main topic will be about nanotechnology in various fields. To begin our program, I would like to introduce first our speakers of the day. Firstly, Chief Executive Officers of Hospital Dr. Yo. Next, Lecturer in Institute of Microbiotechnology, Mr. Harith. Head of Software Engineer and Development, Malaysia, Mr. Haikal. And lastly, Lecturer in Department of Biotechnology in Research Institute, Mr. Jose. Later, they will share their knowledge about nanotech in their field to us. Without any delay, I would like to give all of you a brief explanation about the history of nanotechnology. Originally, the term of nanotechnology firstly used by Japanese professor Norio Taniguchi in 1974 in a contribution to semiconductor processes and possible applications. In 1981, the researchers finally developed a scanning tunneling microscope. By developing the device, the physicists Binning and Rohrer were awarded the Nobel Prize in 1986. As we generally know, nanotechnology deals with manipulation of matter of size of 10 to 9 nanometers. Mostly, scientists did not consider the importance of nanotechnology, not until Richard Feynman gave his speech. One of his famous phrases is, "There is a lot of spaces in the background," which made him an iconic figure of the 20th century, and it affects most of scientists to do more research and innovation in nanotechnology. At the time of the speech of Feynman, a lot of scientific fields have reached their peak, and Richard Feynman was the first to venture to say that in the smallest. Richard Feynman also proposed the example of human body, the manipulation of atoms and life cells, which we all know the DNA, that are important in the functioning of the organism. If it is used in the right way, it can be useful to develop cures for future disease. At the end of 1988 and early 1990s, Eric Drexler, one of famous scientists, developed an idea for the creation and construction complex machines and materials made of single atoms. The consequences of this vision have motivated many scientists to deal critically with the history and development of nanotechnology. There is some application of nanotechnology that our speakers will proudly introduce to all of you, our viewer, and they will also explain about the misunderstanding in their field. At first, I would like to call Executive Officer of Hospital, Dr. Yo, to explain a little bit about nanotechnology in patient therapy. Dr. Yo.
Thank you to our host. And first, I would like to greet all the experts in various fields who are able to attend today's talk show. So now I will be explaining about the usage of nanotechnology in medical field. As you all know, my hospital uses nanotechnology in our patient treatment. Using such technology must have some advantages, otherwise we will not be utilizing it. So what are the pros that we can obtain from it? First of all, the use of nanotechnology has increased the accuracy of diagnostics. Misdiagnosis can be fatal. A misdiagnosis can lead to a patient's death in many cases, which is awful. This is because when patients are misdiagnosed, incorrect therapies are provided that do not cure them at all and may even worsen their condition. The major problem is each symptom can represent one of dozens, if not hundreds, of diseases. It is therefore a challenge for doctors to diagnose the actual illness of their patient for accurate treatment. Medical diagnostics can be made accurate and precise through nanotechnology. The smart pill consists of nanotechnology-based sensor and nanoparticles. It is a kind of capsulated pill that are swallowed by the patient. The smart pill is equipped with a miniature camera that was designed to monitor the bowels or colon for signs of Crohn's disease. In addition, the smart pill can also monitor internal bleeding or polyps. It is able to take picture of our internal, which can be sent to doctor in real time. By this way, the accuracy of diagnostics can be made easier and more accurate. Secondly, I would like to talk about internal wound treatment. When patients encounter minor internal bleeding, we, will, we would use a nanorobot called clotocyte to deal with the problem. Clotocyte is a type of nanorobot that which means artificial mechanical platelet. In a similar way to platelet, clotocyte form blood clot to stop bleeding. Fibers can be stored in the clotocyte until it encounters an internal wound, and after that, it can disperse to form a blood clot. On the other hand, nanotechnology also helps in chemotherapeutics in cancer treatment. DNA was used to create a nanorobot called origami nanorobot to transport molecular payloads. When the nanorobot is injected into the bloodstream, it will actually seek out tumor cells, or commonly we call it as cancerous cells, adsorb to their surface and inject them with a blood clotting enzyme that stops the tumor cell from blood. Due to the lack of blood supply, tumor cell eventually will die. Origami nanorobots can also be responsible in molecular delivery. For example, origami nanorobots can be used to send molecule called pro-apoptotic BCL2 protein that trigger cell suicide in leukemia and lymphoma cells. After my explanation, perhaps you might question what's the difference between clinical medical treatment and nanotechnology therapy. As a matter of fact, nanotechnology can be most effective in places that are impossible for humans to reach, such as the human internal body. For example, just like I explained just now, if someone suffers minor internal bleeding in the colon, it is impossible to perform a surgery, open the stomach, and apply a plaster to stop the bleeding. That's why we use clotocyte nanorobots. To sum up, nanotechnology has improved the efficiency and accuracy of patient treatment through specific molecule delivery and smart internal monitoring. That's all from me. I'll give the time back to our host.
Thank you, Doctor. Without further ado, I'd like to call Mr. Harris, which is lecturer in Institute of Microbiotechnology, to deliver his speech. Mr. Harris.
Thank you, moderator, for giving me an opportunity to continue our discussion about nanotechnology. Before moving on further, allow me to explain briefly about our world condition. Nowadays, we all know that 40 to 50% of our world made up of farmland. The main objective of farming is to increase the output of existing farmland and at the same time to protect our biodiversity, conserving water and reducing pollution. How can we feed every members of growing population with healthy balanced diet and what will the farm future looks like? So friends, I would strongly suggest to use nanotechnology in agriculture extensively. Nanotechnology has the potential to revolutionize agriculture and food production by enabling the development of new materials and devices that can improve crop yields, enhance food safety, and reduce the environmental impact of farming. One way that nanotechnology can be used in agriculture is through the development of nanomaterials for use in fertilizers and pesticides. This nanomaterial can be designed to release nutrients or pest control agents in more targeted area and efficient manner, reducing the need for excess application and minimizing the potential for environmental contamination. Another application of nanotechnology in agriculture is the development of sensors and monitoring systems. This system can use nanostructural materials to detect changes in soil moisture and nutrient levels, allowing farmers to make more informed decisions about when and how much water they need to fertilize their crops. Nanotechnology also can be used to improve food safety by enabling the development of nanobiosensors. For example, nanostructured materials such as nanobiosensor can detect the presence of harmful bacteria at a low concentration, allowing the rapid identification and removal of contaminated product from the food supply chain. Overall, nanotechnology has the potential to significantly impact agriculture and food production by enabling the development of more efficient and sustainable farming practices, improving the safety and quality of food, and reducing the environmental impact of food production. While nanotechnology has the potential to bring many benefits to agriculture and food production, there are also some potential disadvantages that should be considered. One potential disadvantage of nanotechnology in agriculture is the cost. Developing and producing nanomaterial and devices for use in agriculture can be very expensive, which may limit their usage by small-scale farmers or those in developing countries. I think that's all from me. Hopefully, it will give benefit from our discussion today. Thank you.
Wow, there's so much input we can get from him about the agriculture industry. Mr. Haikal looked very ambitious to talk about nanotechnology in IT world. So, Mr. Haikal.
All right, thank you, host. Hi, and good morning to all of you. So, if just now all of you already heard about nanotechnology culture, so now I would like to share more about nanotechnology also, but in different field, which is display and communication technology. All right, what is the main aim for this field? The main aim in this field actually is to understand the nanoscale role and mechanism to implement new information and also communication technology, or also ICT systems that are more economic, portable, and dependable. Nowadays, this field is very important and rapidly growing industrial sector with a high rate of innovation. So, what are the benefits for this nanotechnology field? The benefit for the nanotechnology field is when we're using this technology, it also can improve display screen on electronic devices while reducing power consumption and the weight and thicknesses of the screen. Actually, in this field, we are indicates innovative and advanced technology that permit information through this telecommunication that can make ICT cover any product that capable of storing, manipulating, receiving, or transmitting the information in digital form electronic. Beside in this field, industrial revolution when it's come to the telecommunication industry, it's resulted various changes in the computing, networking, and telecommunication industry. That's why nanotechnology play a major role in this communication field. It has a broad number of applications. There are various ways in which it can influence the telecommunication industry. Various aspects of communication and information technology and their characteristics can be revolutionized by nanotechnology. Actually, nanotechnology has significant function in telecommunication and it can give effective solution to control the physical world and computer processing, power efficient computing, memory improvement program, and human machine interaction. One needs an effective way of communication when he wishes to interact with the other human environments like public places, office, and home. Better sensing and computer resources and get intelligent communication way are provided by electronic devices with a high degree of communication and computing technologies. All right. Moreover, nanotechnology has a huge amount of applications and is make various electronic devices and new material. Nanotechnology can make sensors and computers chip that are considerably cheaper, faster, and more energy efficient and small as compared to their current counterparts. A significant role in play by nanotechnology in the telecommunication field, making a great revolution in various aspects dealing with communication features and technology. A broad of a broad amount of application are possessed by nanotechnology and they have influence in the industry of telecommunication in various ways. And one of the example in this field is wireless technology. The traditional telecommunication enterprise will eventually be replaced by one based completely on the use of the nanotechnology. Nanotechnology enhance this operation of both cellular as well as the core network and providing additional protection and security mechanism. The better effect of This sensor make this technology stand out from previous traditional technologies. In the age of Internet of Things, all smart devices boast some degrees of wireless communication. As we can see from smart home system TV to receiver and satellite to smartphone, and the demand for wireless communication to immerse and is only going to grow. The tech industry in intelligently using all available resources to make all the wireless computation and communication activities seamless. Once nanotechnology has undergone enough development to allow its mass production for use in mobile devices, we will see other surge in the integration of these devices in our everyday life. I think that's all for me. I give him back the station to our host. Thank you.
Thank you very much, Mr. Haika, for that brilliant explanation. Last but not least, as our last speaker for our show, I'd like to call Mr. Jose to give his speech about nanotech in food science. Mr. Jose.
Okay, thank you, Mr. Moderator. A very good morning, I bid to all. As for my part, I'm going to deliver a sharing regarding nanotechnology in food science. Before I dive deeper into my speech, my sharing for today, I just want to express my gratitude that it is a pleasure to be here with everyone, especially with the other three speakers that I am very sure they are experts in their own area. It is a golden opportunity for me to share my knowledge with everyone. Without further ado, let me start. To begin with, I am going to share about the significance of nanotechnology in the food industry. I'm very sure there are lots of benefits of nanotechnology in the food sector, but for today, I will share the vital part of nanotechnology that leaves a huge impact in the industry. Firstly, is the food processing. What is actually food processing? Food processing is the transformation of raw ingredients into food or other forms of marketable and have a long shelf life. Toxin removal, pathogen prevention and preservation, and improving food consistency for better marketing and distribution are all part of the process. Processed foods are less likely to spoil than fresh food and are better suited for long distance transportation from the source to the consumer. All of this, we see that all of this transformation become more efficient and sustainable. Next up is the food packaging. Food packaging necessitates protection, tamper-resistant, and special physical, chemical, and biological requirement. It also displays the product's label to display any nutrition information on the food being consumed. The packaging is definitely an important aspect in preserving the food and making it marketable. Packaging innovation have resulted in quality packaging, a consumer-friendly approach to determining shelf life, biodegradable packaging, and many other benefits. Uh, Moving on to the next one, I'm going to share about the smart packaging. Smart packaging is also another significance of nanotechnology. Sensors are devices that detect the physical quantity of substances and convert the information into observable signals. They are used to regulate the internal environment of food products and their properties are controlled by sensors. While next one is nano barcodes are used for both tagging and security. Thus, the use of smart sensors benefits both consumer and producer by allow better food quality identification and faster distribution and authentication of food products. I think as a conclusion, we can see that there are lots of benefits of nanotechnology that leaves a huge impact to the food industry. It is crystal clear that nanotechnology leaves a huge impact to the food industry. As the conclusion, the wide potential of nanotechnology in the food industry as well as its benefits in providing rich nutritional value, quality packaging, and smart sensing must be considered. And relevant research for safer techniques for incorporating nanotechnology in the food industry must be implemented. I think there's back to the Mr. Moderator. Thank you.
So, what a brilliant explanation from Mr. Jose. Before we end our mock talk for today, any of our speakers would like to briefly explain about misleading from nanotechnology, I guess?
Yes. In my opinion, public do have some misunderstanding about nanotechnology in medical uses. Many argue as following: the nanoparticles are insoluble, therefore it will accumulate in our body and damage our organs. Plus, the nanoparticles are made of metal. Does it has the possibility to harm our health by interacting with our cells? To clarify, the nanoparticles can be categorized based on their materials, such as inorganic-based nanoparticles and organic-based nanoparticles. The inorganic-based nanoparticle that injects into our body is made out of inert matter such as colloidal gold. Therefore, it will not involve it in any kind of chemical reaction or metabolism in our bodies. On the other hand, organic-based nanoparticles made up of organic components such as dendrimers, cellulose, polymeric micelles, and liposomes. Nanotechnology. It is indeed insoluble. However, it can be eliminated from our bodies through the spleen and liver, as spleens and livers have well-developed phagocytes that engulf foreign matter. This organ effectively eliminate nanoparticles. Nanoparticles which are not absorbed by the gut eventually leave the body in the feces. The kidneys and can also filter nanoparticles from the blood and excrete them in the urine. To conclude, nanoparticle must be used in the small amount to prevent accumulation and avoid harmful effects.
For me, from my point of view, I think some people may think that nanotechnology is only relevant to a small group of scientists and has no impact in their daily life. In fact, nanotechnology is already being used in many products that we encounter every day, and its potential application are vast. It is likely that nanotechnology will continue to play an increasingly important role in our daily life in the future. Okay.
Let me add on from my area. I think that in the food industry, I understand that some of you may be concerned about the safety of our food in the presence of nanotechnology. Is it safe for us to eat that food? What you may question that nanoparticles have become an indirect source of food contamination. Next, you ask if the uptake of nanomaterials alters the absorption profile and metabolism in the body. And lastly, the related issue that have been brought to my attention. Let me clarify for today. Firstly, despite no general conclusion has been made by international food authorities on the safety of nano food incorporated with nanomaterials, you need to acknowledge that there is also no evidence that ingested nanomaterials have harmed human health. Secondly, different jurisdictions such as Australia, European Union, United States, and New Zealand have established committees to monitor the development of nanotechnology and take appropriate action if necessary. I think that's all from my part. I'm passing back to Mr. Moderator.
So, that's our closing from our last speaker. We can conclude that nanotechnology have give us a lot of benefits in our industry that will make our life easier. I think that's all from us. Thank you and see you again.
Thank you.